Okay, so welcome back, and today we're going to talk about polygons. Okay, so what is a polygon? A polygon is a closed figure. It's a closed plane figure, okay, with at least 3 angles and at least 3 sides that is closed. Okay, so straight sides, by the way. So that's it. So to consider polygon, which really just means many sides. Poly means many, gon means side, so it's from the Greek. So polygons are shapes, right? They're closed shapes within a plane, right? And how they're created is they're closed, and basically they consist of at least 3 angles, interior angles, and they're formed by at least 3 straight sides. Okay, so here's a bunch of examples of what we would call polygons. Okay, now a couple things to also remember is each one of these, for example, A, B, C. So each one of these are called vertices or a vertex. Okay, the vertex of a polygon. So this would also be a vertex. Okay, now each side is a line segment. Okay, so a line segment is just a straight line that terminates at both ends. Okay, so a line segment is a segment of a line. So this would be segment BC, and we would denote that by using the symbol of BC with a bar over it. Okay, and likewise we would say line segment BA or AB. BA and AB represent the same line segment. Or we could do AC. Okay? Now, diagonal. What is a diagonal? Okay, a diagonal is any line segment that connects any 2 points in a polygon except the points that are adjacent to that point. Okay? For example, this would be a diagonal. This would also be a diagonal. Okay, those would be the only diagonals. Okay, this has no diagonals. Okay, so triangles have no diagonals. This would also. And again, this would also have a diagonal, right? So this would have a diagonal here, and this would also have a diagonal here, and it would also have a diagonal here. But those are not the only diagonals, because I could draw more diagonals from E. So I could draw a diagonal here, and I could draw a diagonal here, and I could draw a diagonal here. Well, I could keep going, right? What if I draw from D? I can draw a diagonal here, from D to B, from D to A, and from D to F, but then I trace over the same line. Okay, so I don't want to count that one twice. Okay, because that's the same diagonal. Okay, and then when I go to C, if I go to C, well, I can go down this diagonal, that's the same, or I can go down this diagonal, that's the same, or I can go down this diagonal, so this is a new one. So there's another diagonal. Okay? And then if you notice that B has 3 diagonals that we've already created, and so is A, and we're right back to F. Okay? So notice that F and E, we had 3 diagonals. And then D had 2 diagonals. Or new. We had to draw 2 new diagonals, and then C only had 1 new diagonal. So if we add up all the diagonals here, how many diagonals do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we end up with 9 diagonals, okay? And then of course we would label those diagonals the same way. So we would label the diagonal AE, so diagonal AE would be the line segment AE, or the line segment BE or EB, okay? And of course we could also label the sides. Oh, and the vertices, right? So this would be vertex E, vertex D, vertex C, right? So we can use single letters to represent the vertex. But then we would have to use double letters or 2 letters to represent each line segment, like we did here, okay? And then of course we could represent the diagonals the same way we do with line segments. Okay, and that's it. Have a great day.